There is a man in rural Japan. He is 96 years old. Every morning, before the sun has fully risen, he walks to his garden. He crouches down. Not slowly, not carefully, not with one hand gripping a fence or a wall. He simply bends his knees and descends fully to the ground. He stays there, working the soil, pulling weeds, planting seedlings, for 2 hours. Then he stands back up. No knee brace, no assistance, no pain medication, no grimace. He just stands. I have been watching people age for over 4 decades. I am Dr. Kenji Watanabe, a physician specializing in longevity and preventive medicine in Japan, and I have spent my career observing what separates the people who remain physically capable into their late 90s from those who lose that capacity decades earlier. And I want to be very direct with you about something. What this man does, what he is capable of at 96, is not miraculous. It is not genetic luck. It is not something reserved for people born in a particular village or blessed with a particular constitution. It is a pattern. A consistent, repeatable, medically observable pattern that appears again and again in certain Japanese populations where elders remain strong, mobile, and largely disease-free well past the age when most people in the Western world have already surrendered their independence to medication, assistive devices, and joint pain. The reason I am making this video is because I keep getting asked the same question. Doctors ask it, researchers ask it, and increasingly, ordinary adults in their 50s and 60s are asking it too. People who are watching their own bodies begin to change in ways that frighten them. The question is always some version of the same thing. Why does this keep happening in Japan? And why isn't it happening where I live? Most of the time, the answers people receive are vague. They are told it is the diet. They are told it is the culture. They are told it is the genetics. These answers are not wrong exactly, but they are incomplete in a way that makes them useless. Because telling someone it is the diet without telling them which foods and why those foods matter biologically and exactly what they do to your body after the age of 50, that is not information. That is noise. So in this video, I am going to take you through what I have observed directly. Not theory, not studies conducted from a distance. What I have seen in the bodies and the lives of Japanese elders who remain functional at ages that most Western adults cannot imagine. I am going to tell you what this 96-year-old gardener eats every single morning before he goes outside. I am going to explain how he moves throughout his day and why that specific movement pattern does something to the joints, the muscles, and the cardiovascular system that structured exercise cannot fully replicate. I am going to show you the single position, a floor position used habitually in Japanese households for generations, that almost certainly explains why this man can still squat at 96 when most 60-year-olds in the United States cannot. I am going to tell you about a mineral present in consistent quantities in the diets of Japanese elders who remain mobile, and that is chronically deficient in Western adults over 50. I am going to walk you through the eating window these elders use and the specific fermented food that appears in their diets almost daily. And then I am going to show you what I observed in Japanese elders who did not age well, the ones who declined early, because understanding what was absent in those patients makes the picture complete in a way that showing only successes cannot. If you are over 50, what you are about to hear is directly relevant to the physical trajectory your body is currently on. Each piece of this connects to the others. What looks like a collection of unrelated habits is actually one coherent biological strategy. And by the end of this video, you will understand exactly what that strategy is and why it works. Let us start with the morning. Before we go any further, if you are watching this and you have been trying to understand why your body feels different than it did 10 years ago, or why people you know seem to be aging at different speeds, this channel is where I share everything I have observed in my clinical work with elderly patients. Every video is structured the same way. Specific information, specific mechanisms, no vague generalities. If that is useful to you, subscribing takes 3 seconds and it means you will not miss what comes next. Now, the morning food. The first thing Hiroshi, that is what I will call this man, though it is not his real name, eats every morning before he goes to his garden is miso soup. Not the kind sold in instant packets in Western supermarkets. Traditional miso soup, made from a fermented soybean paste that has been aged for at least 12 months, combined with dashi, a broth made from dried kelp and fermented fish flakes, and containing 2 or 3 additional ingredients that vary by season. Tofu, wakame seaweed, small vegetables from the garden, sometimes a soft-boiled egg. This is not a remarkable breakfast by Japanese standards. It is what most elderly Japanese people in rural areas have eaten every morning for their entire lives. What is remarkable is what this specific combination does biologically, and why those biological effects become especially important after the age of 50. Let me start with the miso itself. Miso is a fermented food, which means that during the aging process, the proteins, starches, and fats in the soybeans are broken down by beneficial microorganisms, primarily Aspergillus oryzae, a mold that produces enzymes responsible for most of the nutritional transformation. The result of this fermentation is a food that contains a dense concentration of bioavailable nutrients that would not exist in unfermented soybeans, including a full range of essential amino acids, B vitamins including B12, which is rare in plant-based foods, and short-chain peptides that have been shown in multiple studies to have direct anti-inflammatory effects at the cellular level. That last point is important. Inflammation, specifically chronic low-grade systemic inflammation, the kind that does not produce obvious symptoms but that accumulates silently over decades and is now understood to be the primary driver of most of the physical decline associated with aging. Joint deterioration, muscle wasting, cardiovascular disease, cognitive decline. All of these conditions are downstream of the same inflammatory process, and all of them accelerate significantly after the age of 50. Here is what happens at 50 that changes the equation. Before that age, the body has relatively robust mechanisms for controlling inflammatory signaling. Hormones, particularly estrogen and testosterone, play a significant role in suppressing inflammatory pathways. As those hormones decline, and they decline in both men and women, though at different rates and through different mechanisms, the body's ability to regulate inflammation decreases. This is not a disease. It is a normal physiological transition. But it means that what you eat, how you move, and how you structure your day begins to matter in a way that it simply did not when you were 35. The peptides in long-fermented miso have been shown to inhibit specific inflammatory enzymes, including cyclooxygenase 2, which is the same enzyme targeted by NSAIDs, over-the-counter anti-inflammatory drugs like ibuprofen. The difference is that miso does this gently, consistently, without gastrointestinal side effects, and through a mechanism that supports the gut microbiome rather than damaging it. Now add the dashi. Kelp, kombu, is one of the richest natural sources of iodine, fucoidan, and a specific type of soluble fiber that acts as a prebiotic, feeding beneficial gut bacteria. The dried fermented fish in dashi katsuobushi provides a concentrated source of collagen precursors, specifically glycine and hydroxyproline, the two amino acids that are the primary building blocks of collagen in joint cartilage, tendon tissue, and skin. This matters enormously after 50 because collagen synthesis, the body's ability to produce and repair collagen, begins declining significantly in the late 40s and drops sharply through the 50s and 60s. The primary limiting factor in that process is not age itself but substrate availability. The body cannot produce collagen without adequate amino acid precursors, and most Western diets are severely deficient in glycine specifically, because the cuts of meat most commonly consumed in Western countries, muscle meat, contain very little of it. Glycine is concentrated in connective tissue, skin, and bone, the parts of animals that have largely disappeared from Western diets over the past century. Every morning, before he picks up a shovel or bends toward the soil, Hiroshi consumes a bowl of liquid that is simultaneously anti-inflammatory, rich in collagen precursors, prebiotic, and packed with bioavailable minerals from the sea. He has been doing this every day for approximately 80 years. He does not think of it as medicine. It is simply breakfast. But the cumulative biological effect of consuming those compounds daily for 8 decades, during the exact period of life when the body's own anti-inflammatory and collagen synthesis capacity is declining, is, I believe, one of the primary reasons his knees work the way they do. The practical question for someone watching this outside Japan is, can this be replicated? The answer is largely yes, with some attention to sourcing. The key is the quality of the miso. Instant miso packets are pasteurized, which kills the beneficial microorganisms and degrades many of the bioactive peptides. What you want is unpasteurized, traditionally fermented miso. It is increasingly available in health food stores and online in the United States and Europe, often in the refrigerated section. A tablespoon a day in warm, not boiling water, which preserves the beneficial compounds that heat destroys, is sufficient to deliver the relevant biological effects. Kombu and katsuobushi dashi can be made in 5 minutes with dried ingredients, or substituted with a high-quality kelp broth as a starting point. The principle is the combination: fermented soybean base, marine minerals, collagen precursors, consumed warm, in the morning, before physical activity. That combination, consumed consistently, is not a supplement protocol. It is food, and it is what this man's body has been running on since before most people watching this were born. When I talk about how Hiroshi moves throughout his day, I want to be precise about something, because there is a distinction that matters medically and that most people miss entirely when they think about physical activity in old age. Hiroshi does not exercise. He has never had an exercise routine. He has no gym membership. He does not go for structured walks at a specific time with specific goals. What he does, and what I have observed in virtually every Japanese elder over 85 who has maintained strong physical function, is move continuously at low intensity throughout most of his waking hours. He walks to the market. He tends his garden. He carries things. He climbs stairs. He cooks. He cleans. He sits on the floor and stands back up multiple times per day because his home is structured in a way that requires it. This is not the same thing as exercise, and the biological distinction is not minor. When you perform structured exercise, a 30-minute walk, a weight session, an aerobics class, you elevate your heart rate and your metabolic activity for that period, and then you stop. If the rest of your day is sedentary, your body spends 23.5 hours in a low-activity state. And research conducted over the past 15 years has made something very clear. Extended periods of sitting, not the absence of exercise, but the continuous uninterrupted presence of sitting, produce specific metabolic and inflammatory consequences that exercise, even vigorous exercise, does not fully counteract. This has been called the active couch potato effect. People who exercise regularly but sit for the remainder of the day show metabolic markers that are not substantially better than people who do not exercise at all. What Hiroshi does is the opposite of this. He does not have high-intensity intervals, but he also does not have extended sedentary intervals. His movement is continuous, integrated into every function of his daily life, distributed across the entire waking day in a way that keeps his metabolic state permanently elevated above baseline. The specific biological consequences of this pattern are measurable. Continuous low-intensity movement stimulates what is called non-exercise activity thermogenesis, the calories and metabolic activity generated by all movement that is not formal exercise. In populations where this is high, insulin sensitivity is significantly better, resting inflammatory markers are lower, and muscle mass is preserved more effectively into old age. This is relevant because muscle mass is not simply a measure of strength. Muscle tissue is metabolically active. It consumes glucose, it secretes anti-inflammatory compounds called myokines, and it serves as the primary reservoir of amino acids that the body draws on for tissue repair. Losing muscle mass after 50 is not just a physical performance issue. It is a systemic health issue that accelerates virtually every other form of age-related decline. Joint lubrication is another direct benefit of continuous movement that is poorly understood by most people. Synovial fluid, the fluid inside your joints that prevents cartilage from grinding against cartilage, is not pumped by the heart. It is circulated by movement. The compression and decompression of joint cartilage during normal movement is what drives fresh synovial fluid into the joint space and pushes waste products out. A joint that does not move for extended periods becomes progressively less well lubricated. This is why people who sit for most of the day feel stiff when they stand up, and why that stiffness tends to become more pronounced and more persistent over the years. The cartilage is not being adequately nourished. For someone living in a Western context where work, transportation, and leisure are all structured around extended sitting, replicating Hiroshi's movement pattern exactly is not realistic. But the underlying principle is, the goal is not to add exercise to a sedentary life. The goal is to reduce the length of uninterrupted sedentary periods throughout the day. Standing up and moving for 2 to 3 minutes every 30 to 40 minutes, not as exercise, but as a disruption to the sedentary state, has been shown to meaningfully improve the metabolic and inflammatory markers associated with prolonged sitting. It is not the same as spending your day gardening, but it operates on the same biological principle, and it is achievable in an ordinary working life. What I want you to understand is that the capacity Hiroshi has at 96, the ability to squat, to work, to move without pain, was not preserved by what he did in any particular moment. It was preserved by what he did continuously, across thousands of days, without interruption. Physical capacity in old age is not lost suddenly. It declines gradually through the cumulative effect of movement patterns chosen or defaulted to over decades. The difference between the person who can squat at 96 and the person who cannot squat at 60 is, in most cases, not biology. It is daily pattern. I want to talk about one specific physical practice that I believe deserves more attention from Western medicine than it currently receives, because in my observation of elderly patients over decades, it is one of the most consistent predictors of preserved lower body mobility in advanced age. That practice is floor sitting. In traditional Japanese households, and Hiroshi's home is a traditional one with tatami mat rooms, low tables, and cushions on the floor rather than chairs. Sitting on the floor is not something reserved for children or for special occasions. It is the default position for eating, for socializing, for watching television, for reading. Adults in these households lower themselves to the floor and rise from the floor multiple times per day, every day throughout their entire lives. This habit, practiced continuously across a lifetime, produces specific and measurable effects on the musculoskeletal system that are directly relevant to the ability to squat without pain in old age. The squat is not simply a leg exercise. It is a compound movement that requires adequate mobility at 3 joint complexes simultaneously: the ankle, the knee, and the hip. If any one of these 3 is restricted, if the range of motion available at the ankle, the knee, or the hip is insufficient, the squat either becomes impossible or is performed in a compensated way that places excessive stress on the joints that do have mobility, typically the lower back. Ankle dorsiflexion is the range of motion that allows the shin to travel forward over the foot as you lower into a squat. It is controlled primarily by the flexibility of the calf musculature and the mobility of the ankle joint itself. In adults who spend most of their waking hours in shoes with elevated heels and in chairs, ankle dorsiflexion decreases progressively over decades. The calf muscles adaptively shorten. The ankle joint becomes restricted, and without adequate ankle dorsiflexion, a full squat becomes biomechanically impossible without compensations. Hip mobility, specifically the ability of the hip joint to flex fully and to rotate both internally and externally, is similarly affected by decades of chair sitting. When the hip is held in a fixed flex position for hours at a time, every day the hip flexors, particularly the iliopsoas, adaptively shorten. The posterior hip capsule becomes restricted. The range of motion available for deep hip flexion decreases. This is compounded by the loss of external rotation, which is required for a comfortable, stable squat. Floor sitting addresses both of these deficiencies through a mechanism that most Westerners have never thought about: passive, sustained loading at end range. When you sit on the floor, particularly in the cross-legged position known as seiza in Japanese culture, or in a half-kneeling or full squat rest position, you are placing the hip and ankle joints at or near their end range of motion and holding them there, supported by body weight, for extended periods. You are not actively stretching. You are simply using these positions as your resting positions, which means that over a lifetime, your joints spend enormous amounts of time at ranges of motion that chair-sitting populations almost never access. The biomechanical consequence of this, accumulated over decades, is that the connective tissue structures, the joint capsules, the ligaments, the tendons, remain supple and functional at ranges of motion that atrophy from disuse in people whose joints spend their entire adult life in the narrow range permitted by a chair. There is also a neuromuscular component. Rising from the floor without assistance requires coordinated activation of the glutes, the quadriceps, the core stabilizers, and the smaller intrinsic muscles of the hip. Performing this movement multiple times daily, every day, is low-intensity functional strength training for exactly the muscle groups that are required for lower body independence in old age. People who stop getting up from the floor, who switch to chairs, to elevated toilet seats, to beds with rails, lose not just the range of motion but the neuromuscular pattern that makes the movement possible. I have seen this pattern reverse. I have seen patients in their 70s who had lost the ability to sit on the floor, who found it painful and frightening, gradually recover that capacity over months by reintroducing floor sitting in supported ways, starting with a wall behind them, progressing to independence. The connective tissue responds. The neuromuscular patterns rebuild. The range of motion returns. Not always completely and not quickly, but the human body retains more plasticity in its 7th and 8th decade than most people believe. For someone who has spent decades in chairs, the practical introduction of floor sitting requires patience and possibly support. Beginning with a folded blanket under the hips to reduce the range of motion required, or using a wall for support, allows the tissues to adapt gradually without producing pain that stops the practice before it can produce benefit. The goal is not to suffer on the floor. The goal is to progressively reintroduce the end-range loading that decades of chair sitting have removed from your body's daily experience. Even 20 minutes of floor sitting per day, built gradually over months, will produce measurable changes in hip and ankle mobility over time. Hiroshi has never sat in a chair for any extended period in his life. He does not know what it feels like to have restricted hips or limited ankle mobility, because those restrictions require decades of disuse to develop. His joints are, in a very literal sense, the product of a lifetime of use across their full range. If I had to identify one nutritional deficiency that I see most consistently in Western adults over 50 who are experiencing accelerating physical decline, joint pain, muscle weakness, cramps, fatigue, increased fall risk, it is magnesium. And if I look at the diets of Japanese elders like Hiroshi who are not experiencing those symptoms at 96, magnesium is present in consistent, significant quantities in almost everything they eat. This is not a coincidence, and the mechanism is not subtle. Magnesium is involved in over 300 enzymatic processes in the human body. That number is not rhetorical. It is a measured fact from biochemical research, and it means that when magnesium is deficient, even marginally deficient, hundreds of biological processes are simultaneously impaired. Among the most clinically relevant in the context of aging and physical function are the following: muscle contraction and relaxation. Magnesium is the mineral that allows muscle fibers to release after contraction. Calcium triggers contraction. Magnesium terminates it. When magnesium is insufficient, muscles contract more easily and relax with greater difficulty. The most obvious symptom of this is cramping, the sudden, involuntary, painful contraction that does not release quickly. But the same mechanism produces subtler chronic effects: elevated resting muscle tension, reduced strength output, and impaired recovery after physical activity. In older adults, chronic low magnesium contributes directly to the progressive muscle stiffness that most people assume is simply a feature of aging. Nerve function and pain signaling. Magnesium acts as a natural calcium channel blocker in nerve cell membranes, meaning it modulates the sensitivity of nerve cells to pain signals. Low magnesium is associated with increased pain sensitivity, technically called central sensitization, which means that the same joint, under the same physical stress, will produce a stronger pain signal in a magnesium-deficient person than in a person with adequate levels. This is directly relevant to the experience of joint pain in older adults. Some proportion of the joint pain experienced by adults over 50 is not from additional structural damage but from heightened pain signaling that is driven in part by inadequate magnesium. Bone density. Magnesium is required for the activation of vitamin D, the conversion of the storage form of vitamin D in the liver to its active hormonal form, which regulates calcium absorption in the gut. Without adequate magnesium, vitamin D supplementation is substantially less effective. And without adequate calcium absorption, bone density declines. This is the reason that populations with high vitamin D supplementation and high calcium intake but low magnesium intake do not show the bone density improvements that the supplementation protocol would theoretically predict. Now, how deficient are Western adults over 50? Surveys consistently show that 60 to 70% of adults in the United States do not meet the recommended daily intake of magnesium from food. And the recommended daily intake, approximately 310 to 420 milligrams per day depending on age and sex, is itself a minimum threshold for avoiding deficiency, not an optimal level for aging well. After 50, magnesium absorption from food decreases due to changes in gut function, and the kidneys excrete more magnesium in older adults than in younger ones. Proton pump inhibitors, acid reflux medications taken by enormous numbers of older adults, further reduce magnesium absorption. The practical result is that many older adults are running a consistent magnesium deficit that grows worse with each passing year. In traditional Japanese diets, magnesium is delivered primarily through three sources. First, tofu and other soy products. Tofu made with the traditional coagulant nigiri, which is magnesium chloride, is exceptionally rich in magnesium. A single serving of firm tofu provides approximately 37 milligrams. Second, seaweed, particularly wakame and hijiki, are among the most magnesium-dense foods on Earth. Third, whole grains, particularly the short-grain brown rice and barley that appear in the diets of traditional Japanese elder populations, provide consistent magnesium across the day. Hiroshi eats all of these foods every day. He does not take magnesium supplements because he has never needed to. His diet has been delivering adequate magnesium through food for his entire life, during the period when his gut was absorbing it efficiently and during the period when it was not, because the quantities in his diet are high enough to compensate for reduced absorption. For Western adults, the practical path to improved magnesium status begins with food. Dark leafy greens, particularly spinach and Swiss chard, are among the best Western sources. Pumpkin seeds, almonds, black beans, and whole grain products all contribute meaningfully. Where food intake is insufficient, supplementation with magnesium glycinate or magnesium malate, forms that are well absorbed and less likely to cause gastrointestinal upset, is a reasonable adjunct. There is something about the way Hiroshi eats that has nothing to do with which foods he chooses and everything to do with when he stops. In his household, and in the households of most traditional Japanese elders I have observed in rural areas, the evening meal ends early. Not 10 o'clock, not 8 o'clock, more commonly 5:30 or 6 in the evening. After that, the kitchen is closed. Perhaps a cup of green tea, perhaps a small amount of water. Nothing else until morning. This is not a consciously adopted dietary protocol. It is not what, in Western health circles, would be marketed as intermittent fasting or a 16-8 eating window. It is simply when these people have always eaten. Early dinners that reflect the schedule of a farming community where the day begins before dawn and ends shortly after dark. But the biological consequences of this timing are significant enough that I want to explain the mechanism in some detail. Your body operates on a circadian clock, a set of internal biological timers that regulate virtually every physiological process according to a 24-hour cycle. These timers exist not just in the brain but in every cell of the body, including the cells of the gut, the liver, the pancreas, and the adipose tissue. And they are synchronized or desynchronized by two primary signals: light exposure and food consumption. When you eat late at night, you are sending food to a digestive system whose enzymatic activity, insulin sensitivity, and glucose processing capacity have already begun downregulating for the night. The pancreas secretes less insulin in the evening than in the morning in response to the same glucose load. The liver processes nutrients less efficiently. The gut motility slows. This is not malfunction, it is normal circadian physiology. But it means that a meal eaten at 9 o'clock at night produces a substantially larger and more prolonged blood glucose and insulin response than the same meal eaten at noon. And it is that elevated insulin response, repeated night after night across years and decades, that contributes to the progressive insulin resistance that underlies most metabolic disease. Beyond glucose metabolism, late eating disrupts a process that is critical for cellular health: autophagy. Autophagy is the body's internal cellular maintenance system, a process by which cells identify and break down damaged proteins, dysfunctional organelles, and other cellular debris that accumulates over time. Think of it as the body's overnight cleaning cycle. It is activated by the absence of food, specifically by the drop in insulin and the rise in a cellular signaling molecule called AMP-activated protein kinase that occurs when the digestive system is not actively processing a meal. Autophagy is most active in the late night and early morning hours, precisely the window that is occupied by food digestion in people who eat their last meal at 9 or 10 at night. The consequence of chronically suppressed autophagy is accelerated cellular aging. Damaged proteins accumulate in cells instead of being cleared. Dysfunctional mitochondria, the energy-producing structures inside cells, are not removed efficiently. This cellular debris buildup contributes to the chronic low-grade inflammation that is now understood to drive most of the physical decline associated with aging. The relationship between late eating, impaired autophagy, and elevated inflammatory markers has been documented in multiple clinical studies over the past decade. Joint tissue is specifically vulnerable to this mechanism. Synovial cells, the cells that line joint cavities and produce synovial fluid, are among the cells that depend heavily on autophagy for maintenance. When autophagy is chronically impaired, synovial cell function degrades, synovial fluid quality declines, and the inflammatory environment within the joint worsens. This is not a theoretical pathway. Studies of arthritic joint tissue consistently show impaired autophagic activity in the affected cells. Hiroshi's body has, every night for 96 years, had approximately 13 to 14 hours without food, from dinner at 5:30 or 6 until his morning miso soup at 7 or 7:30. During those hours, his cellular maintenance systems have been operating without the interruption of incoming nutrients. His cells have been cleaning themselves. His inflammatory load has been declining through the night. And then, when food arrives in the morning, it arrives into a system that has been appropriately resting and is now metabolically prepared to handle it. For someone in a Western context, adjusting the eating window is one of the more structurally challenging changes to implement, because evening eating is deeply embedded in social and cultural patterns. But the biology does not negotiate. What I would suggest is a gradual shift, moving the last meal earlier by 30 minutes per week over the course of 2 months, rather than an abrupt change that creates resistance and is not sustained. The goal is not to skip breakfast or to count hours. The goal is to allow the body's overnight maintenance systems to operate in the window of time that physiology has allocated to them. That window exists in every human body. The question is whether the eating pattern allows it to function. Every morning, Hiroshi's miso soup contains fermented soybean paste. Most days, his lunch or dinner includes another fermented food, natto. And several times per week, his meals include pickled vegetables. Sukmano, made by fermentation rather than vinegar pickling, which is the key distinction. I want to focus on natto specifically because it is the fermented food most consistently associated with the dietary patterns of long-lived Japanese populations, particularly in the regions where centenarian density is highest, and because it does something specific that most fermented foods do not. Natto is made from soybeans that have been fermented with a bacterium called Bacillus subtilis var. Natto, the fermentation process transforms the soybeans in several ways. It significantly increases the bioavailability of the nutrients present. The proteins become easier to digest. The minerals are more readily absorbed. It produces a range of enzymes, most notably nattokinase, which has been extensively studied for its effects on blood coagulation and cardiovascular health. And it produces one of the highest known food source concentrations of vitamin K2, specifically the -7 Malawian Quachas form, of any food on Earth. That last point is where I want to spend some time, because vitamin K2 is poorly understood in Western medicine and is almost certainly one of the key nutritional reasons why traditional Japanese diets are associated with dramatically lower rates of both cardiovascular disease and osteoporosis than the standard Western diet, even when calcium intake is comparable. Here is the mechanism. Calcium is an essential mineral for bone density, but it does not naturally navigate to where you want it in the body. Without adequate vitamin K2, calcium absorbed from the gut tends to deposit in soft tissues, arterial walls, kidney tissue, joint spaces, rather than in bone. Vitamin K2 activates two specific proteins, osteocalcin, which binds calcium into bone matrix, and matrix GLA protein, which actively inhibits calcium deposition in arterial walls. Without K2, both of these proteins remain inactive. The result is a situation where calcium supplementation without adequate K2 can simultaneously fail to build bone density and contribute to arterial calcification, a combination that is, in simple terms, the worst possible outcome. In the Western diet, K2 is nearly absent. It is found in meaningful quantities in grass-fed animal fats, aged cheeses, and fermented foods, none of which are present in significant amounts in the standard modern diet. Vitamin K1, found in leafy greens, is abundant in Western diets, but K1 and K2 perform different biological functions, and the body converts K1 to K2 very inefficiently. The result is that most adults in Western countries are functionally K2 deficient, even if they eat vegetables regularly. A single serving of natto, approximately 100 grams, contains approximately 870 micrograms of -7 Malawian Quachas, which is many times more than the estimated daily requirement and substantially more than any other food source. Populations that eat natto regularly have measurably higher bone density, lower rates of osteoporotic fracture, and lower rates of arterial calcification than comparable populations that do not, even within Japan, where comparing natto-consuming regions to non-natto-consuming regions has produced some of the most compelling nutritional evidence for K2's role in healthy aging. Beyond K2 and nattokinase, natto contributes to the gut microbiome. Bacillus subtilis survives gastric transit and colonizes the gut temporarily, where it produces bacteriocins, compounds that suppress pathogenic bacteria, and contributes to the overall microbial diversity that is strongly correlated with immune function and inflammatory regulation. This is where the gut's role in aging becomes relevant. The gut microbiome is now understood to be a primary regulator of systemic inflammation. A diverse, well-populated microbiome produces short-chain fatty acids, particularly butyrate, that reduce inflammatory signaling throughout the body, including in joint tissue and in the brain. A depleted or dysbiotic microbiome produces the opposite: elevated inflammatory cytokines that circulate systemically and contribute to the joint pain, fatigue, and cognitive changes that many adults over 50 attribute purely to age. After 50, the gut microbiome becomes progressively less diverse in most people, for reasons that include reduced dietary fiber, increased antibiotic use, and the gradual decline of the gut's mucosal immune system. Fermented foods are one of the most effective dietary interventions for maintaining or restoring microbiome diversity, not through permanent colonization, which most beneficial organisms from food do not achieve, but through the consistent delivery of living microorganisms that transiently support the microbiome's function and through the fermentation byproducts that feed the organisms already present. Hiroshi eats fermented foods every day. He always has. His gut microbiome has been continuously supported by that input for 9 decades. For someone in a Western context, natto is available in Japanese grocery stores in most major cities and increasingly in health food stores. Its flavor and texture are unusual by Western standards. It is sticky, strongly flavored, and pungent. But consumed with rice and a small amount of soy sauce and mustard, as Hiroshi eats it, it is a complete, nutritionally dense meal component. If natto is not accessible or acceptable, traditionally fermented kimchi, high-quality unpasteurized miso, and traditional kefir made from whole milk are meaningful alternatives that deliver comparable microbiome support, though without the K2 concentration that makes natto specifically exceptional. I want to tell you about the other patients, because I think this section of what I am going to share with you is, in some ways, the most important, and it is the section that almost nobody talks about. Over 40 years of clinical practice in Japan, I have cared for hundreds of elderly patients. Some of them were like Hiroshi, mobile, strong, clear-minded, largely disease-free well into their 80s and 90s. But not all of them were. And among those who declined early, who lost mobility in their 60s and 70s, who developed chronic joint pain, who became dependent on medication and assistance at ages when others were still gardening, there were patterns. Specific, consistent, identifiable patterns in what those patients ate, how they moved, and how they had structured their lives in the decades before they came to see me. I am going to tell you what those patterns were. Not because I want this video to be discouraging, but because the absent side of this picture makes the mechanism clearer than the present side alone ever can. The first and most consistent pattern I observed in patients who declined early was the abandonment of floor living. These were Japanese adults who had, at some point in their 40s or 50s, made the transition to Western-style furniture, raised beds, sofas, chairs at dining tables, often as a status symbol or for comfort. By the time they were in their 60s and 70s, they had lost the hip and ankle mobility required to sit on the floor. They could no longer perform the movement patterns that their own culture had preserved for centuries, and they experienced the physical consequences of that loss. Decreased lower body strength, increased fall risk, and the progressive loss of independence that follows from being unable to safely lower and raise themselves from ground level. The second pattern was the adoption of what I think of as retired stillness. These patients had worked physically active lives, farming, fishing, manual trades, and when they retired, they stopped. They sat. They watched television. They rested because they believed they had earned the rest, and in a social sense, they had. But biologically, the abrupt removal of continuous daily movement produced a cascade that was almost immediately measurable in their lab results. Rising inflammatory markers, declining insulin sensitivity, loss of muscle mass at rates that accelerated the longer the inactivity continued. Muscle mass, once lost in a sedentary older adult, is extraordinarily difficult to rebuild. The anabolic response to protein and resistance stimulus declines with age, which means that preventing muscle loss is dramatically easier than recovering it. The third pattern, and this one is directly relevant to dietary habits, was the shift away from fermented foods. Among my patients who had moved to cities or who had adopted more westernized eating patterns, consumption of miso, natto, sukmino, and other traditionally fermented foods had decreased significantly. In their place were processed foods, refined carbohydrates, and protein sources that were higher in inflammatory omega-6 fatty acids. The gut microbiome changes associated with this dietary shift became evident in these patients' immune function, in their inflammatory markers, and, over time, in their joint health and their cognitive clarity. The fourth pattern, which I observed most clearly in patients who experienced accelerated cardiovascular decline and osteoporosis, was the replacement of traditional dietary fats and fermented foods with low-fat processed products that had been introduced into Japan as health food during the 1970s and 1980s. These patients had, with entirely good intentions, removed the fermented foods and animal fats from their diets that were, I now understand, delivering K2 and other fat-soluble compounds essential for calcium regulation and arterial health. Their bone density was lower than patients who had maintained traditional eating patterns. Their arterial calcification was higher. They had followed advice that was genuinely intended to help them and had been measurably harmed by it. What I want you to take from this is not a counsel of despair. The patients who declined early were not defective people. They were people who made choices, some driven by preference, some by cultural assimilation, some by medical advice that turned out to be wrong, that altered the biological trajectory their bodies were on. And in some cases, when those choices were reversed, the trajectory changed. Not always completely, not always quickly, but measurably. The gap between Hiroshi and the patients who were struggling in their late 60s was not created in old age. It was created over decades, through the cumulative weight of daily choices that seemed small in the moment and became large over time. The patients who had maintained floor-sitting, continuous movement, fermented foods, and an early dinner had bodies in their 80s that functioned like the bodies of people 20 years younger. The patients who had abandoned those practices had bodies in their 60s that were already beginning to fail. This is the mechanism in its clearest form. Not dramatic interventions, not therapeutic breakthroughs, but the arithmetic of daily habit across decades. By this point in the video, you have heard about miso soup, about continuous movement, about floor sitting, about magnesium, about early dinners, about natto, and about what I observed in patients who declined. These might seem like a collection of unrelated habits, specific to a culture, interesting but not obviously connected. They are connected. There is one biological thread running through every single one of them, and once you see it, the entire picture becomes coherent in a way that no individual piece of it can be. The thread is the management of systemic inflammatory load across time. Everything Hiroshi does, every food he eats, every way he moves, every structural decision about when to eat and how to sit, either directly reduces inflammatory signaling in his body or supports the biological systems whose function is to regulate inflammation. And everything I observed in the patients who declined early, the stillness, the processed foods, the late eating, the abandonment of floor living, either directly increased inflammatory load or degraded the systems that would otherwise have controlled it. Chronic low-grade systemic inflammation is not a single disease. It is a background condition, a state of the body in which inflammatory signaling is elevated above the baseline appropriate for a healthy adult, and in which the regulatory mechanisms that would normally bring it back down are progressively impaired. It accumulates. It does not produce dramatic symptoms in its early stages. It produces subtle ones. Slightly more joint stiffness in the morning, slightly more fatigue than expected, slightly slower recovery from minor injuries. These symptoms are so gradual that most people attribute them to aging, and then accept them. But what the population of Japanese elders like Hiroshi demonstrates, consistently across multiple generations, across regions, across studies comparing them to other populations, is that this accumulation is not inevitable. It is the result of specific conditions. And those conditions are, to a significant degree, modifiable through the daily choices of ordinary life. Every fermented food Hiroshi consumes delivers bioactive compounds that directly downregulate inflammatory enzymes. Every hour of continuous movement clears inflammatory metabolites from his blood and joints more effectively than sedentary periods allow. Every night that he stops eating at 6 in the evening gives his body 14 hours to activate autophagy, the cellular process that clears the damaged proteins and dysfunctional structures whose accumulation is itself a primary driver of inflammatory signaling. Every time he lowers himself to the floor and rises back up, he delivers fresh synovial fluid to joint surfaces that would otherwise be starved of it. The magnesium in his food quiets nervous system hypersensitivity. The K2 in his natto directs calcium away from his arterial walls and into his bones. None of these effects is large in isolation. That is precisely the point. The body does not change in response to dramatic interventions nearly as much as it changes in response to the direction of small, consistent daily inputs over years. The biological difference between a body that has been running a low inflammatory load for 60 years and one that has been running a high inflammatory load for the same period is not a difference in genes or luck. It is a difference in cumulative arithmetic. I am not presenting this as a guarantee. Biology is not simple and individuals vary. But the pattern I am describing is not anecdotal. It is visible in the epidemiological data comparing Japanese elder populations to Western ones. It is visible in the laboratory values of patients who maintain these habits versus those who abandon them. It is visible in the body of a 96-year-old man who squats in his garden every morning without pain, in a way that most people reading this cannot do at 60. The question this video is designed to answer is not whether it is possible to remain physically functional into extreme old age. The evidence that it is possible is standing in a garden in rural Japan right now. The question is what produces that outcome, what biological mechanism is operating in that body that is not operating in bodies that declined 30 years earlier. And the answer, as I hope this video has made clear, is not a single food, a single habit, or a single decision. It is a consistent, decades-long practice of keeping the body's inflammatory load low, through every available means that daily life provides. What I will address in the next part of this discussion is what happens when someone attempts to begin this practice later in life, in their 50s, 60s, or even 70s. How much of the capacity that has been lost can realistically be recovered, and through what sequence of changes? That is where we will go from here. If you made it to the end of this video, you now understand something that most people who talk about Japanese longevity do not explain: the mechanism. Not just what these elders do, but why, biologically, it works, and what specifically goes wrong when it is not done. That is the difference between information you can act on and information that merely sounds interesting. The next video in this series will address what happens when someone starts these changes later, in their 50s, 60s, or 70s, how much physical decline is reversible, and in what order these habits should be introduced for the greatest impact. If you want to see that when it comes out, subscribe and turn on notifications. And if this video gave you something genuinely useful, leaving a comment about which part was most relevant to you helps this content reach other people who need it. That is all. Thank you for watching.